All the participants in the study I'm going to tell you about this week died. And 3 of them died twice. But their deaths provide us a fascinating window into the complex electrochemistry of the dying brain. What we might be looking at, indeed, is the physiologic correlate of the near-death experience. The concept of the near-death experience is culturally ubiquitous, and though the content seems to track along cultural lines, Western Christians are more likely to report seeing guardian angels, while Hindus are more likely to report seeing messengers of the god of death, certain factors seem to transcend culture: an out-of-body experience, a feeling of peace, and, of course, the light at the end of the tunnel. As a materialist, I won't discuss the possibility that these commonalities reflect some metaphysical structure to the afterlife. More likely, it seems to me, is that the commonalities result from the fact that the experience is mediated by our brains, and our brains, when dying, may be more alike than different. We're talking about this study appearing in the Proceedings of the National Academy of Sciences by Jimo Borjigin and her team. Dr. Borjigin studies the neural correlates of consciousness, perhaps one of the biggest questions in all of science today, to wit, if consciousness is derived from processes in the brain, what set of processes are minimally necessary for consciousness? The study in question follows 4 unconscious patients, comatose patients, really, as life-sustaining support was withdrawn to the moment of death. 3 had suffered severe anoxic brain injury in the setting of prolonged cardiac arrest. Though the heart was restarted, the brain damage was severe. The 4th had a large brain hemorrhage. All 4 patients were thus comatose and, though not brain dead, unresponsive, with the lowest possible Glasgow Coma score, no response to outside stimuli. The families had made the decision to withdraw life support, to remove the breathing tube, but agreed to enroll their loved one in the study. The team applied EEG leads to the head, EKG leads to the chest, and other monitoring equipment to observe the physiologic changes that occurred as the comatose and unresponsive patient died, as the heart rhythm evolved from this to this and eventually stopped. But this is a study about the brain, not the heart. Prior to the withdrawal of life support, the brain electrical signals look like this. What you see is the EEG power at various frequencies, with red being higher. All the red was down at low frequencies. Consciousness, at least as we understand it, is a higher frequency phenomenon. But right after the breathing tube was removed, the power didn't change too much, but you can see some increased activity at the higher frequencies. And then in 2 of the 4 patients, something really surprising happened. Watch what happens as the brain gets closer and closer to death. Here, about 300 seconds before death, there is a power surge at the high gamma frequencies. This spike in power occurred in the somatosensory cortex and the dorsolateral prefrontal cortex, areas which are associated with conscious experience. It seems that this patient, 5 minutes before death, was experiencing something. But I know what you're thinking. This is a brain that's not receiving oxygen. Cells are going to become disordered quickly and start firing randomly, a last gasp, so to speak, before the end. Meaningless noise. But connectivity mapping tells a different story. The signals seem to have structure. Those high-frequency power surges increased connectivity in the posterior cortical hot zone, an area of the brain many researchers feel is necessary for conscious perception. This figure is not a map of raw brain electrical output like the one I showed before, but of coherence between brain regions in the consciousness hot zone. Those red areas indicate crosstalk, not the disordered scream of dying neurons, but a last set of messages passing back and forth from the parietal and posterior temporal lobes. In fact, the electrical patterns of the brains in these patients looked very similar to the patterns seen in dreaming humans, as well as in patients with epilepsy who report sensations of out-of-body experiences. Now, it's critical to realize 2 things here. First, that these signals of consciousness were not present before life support was withdrawn. These comatose patients had minimal brain activity. There was no evidence that they were experiencing anything before the process of dying began. These brains are behaving fundamentally differently near death. But second, we must realize that although the brains of these individuals in their last moments appeared to be acting in a way that conscious brains act, we have no way of knowing if the patients were truly having a conscious experience. As I said, all the patients in the study died. Short of those metaphysics I alluded to earlier, we will have no way to ask them how they experienced their final moments. Let's be clear, this study doesn't answer the question of what happens when we die. It says nothing about life after death or the existence or persistence of the soul. But what it does do is shed light on an incredibly difficult problem in neuroscience, the problem of consciousness. And as studies like this move forward, we may discover that the root of consciousness comes not from the breath of God or the energy of a living universe, but from very specific parts of the very complicated machine that is the brain, acting together to produce something transcendent. And to me, that is no less sublime. For Medscape, I'm Perry Wilson.